Welcome back to another Daishinfinity video. In this video, we're going to talk about logic in about absorption, commutativity, and the opposite of absorption and commutativity. So we have two variants of absorption and commutativity. With absorption, I mean that if we have a statement A and a statement B, then we have that A and A or B is equal to A. And if we have a statement A and B with A or A and B, then the statement will be A2. For commutativity, it is just saying that if we have a statement A and B, it is the same thing as saying B and A. And the same thing for A or B, that this this is equivalent to B or A. So this is what we are going to prove in this video. So let's try and prove this by using a table. So let's say A is a statement and B is a statement. Then A and B can be either true or false. So I'm going to use T for true and false for F. F for false. Then we have that B can be true, which means that A and B are both true, or we can have that A is true but B is false, or we can have that A is false and B is true, and we can have that both are false. So both are incorrect. Then we can combine them saying A or B, and we can say A and B. And at the end, we have to show that A and A or B. I'm sorry. A and A or B. And A or A and B is equivalent to saying it's the statement A. So let's just start by saying A or B. A or B means that if one of them is true, then everything is true. So the statement is true for the first one since both of them are true. The second one is also true since A is true. The third one is also true since B is true. And both of them are false, which means nothing is true, so everything is false. Then we have A and B, which means if one is false, everything is false. So nothing is false, which means this is a true statement. And here we have one false statement, and here we have another false statement, and here we have two false statements. So now we can see differences. Now I want you to try and prove this. Well, I'm going to prove this. A, as we normally had, A was true, true, false, false in this kind of way. So if we have true, true, false, false, A and A or B means that the statement A or B and A should both have only trues, then the statement is true. Or if one of them is false, everything will be false. So what it means is that since both of them are true, it is true. Here we can see true and true, so we can see it's true. Here we can see true and false, so it's false. And here we can see false, false, so it's false. And now we can see that it is equivalent to saying A is equivalent to saying A and A or B. And on the other hand side, we have A or A and B. And here we can see A is true, true, false, false, and A or B, A and B, I'm sorry, is true, false, false, false. So if we say A or A and B, then one of them should be true, that everything is true. So the first one, both of them are true, so it's true. The second one is true, so it's also true. And the third one, both of them are false, so it's false. And the both of them are false, so it's also false. Which means this A and this A or A and B is also equivalent. Which means at the end we can say A is equivalent to saying A and A or B, which is also equivalent to saying A or A and B. Okay, now let's start using commutativity, and let's show that commutativity is also same. So let's say A and B are statements. So if A and B are statements, then A can be true or false. And B can be true, false, true, false. Since we have to have every combination between true and false. Okay, then A and B, which means if one is false, everything is false, which means this is true, this is false, this is false, this is false. B and A, so we are looking at B first, doesn't make any difference because if I have 3 plus 5, it's the same thing as saying 5 plus 3. So we can say this is also true, false, false, false. So we can here clearly say that these are equivalent. And we can try to prove A or B. A or B means if one is true, everything is true. So this is true, this is true, this is true, this is false. And B or A means that we are looking at B first, but it doesn't make any difference. So true, 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 false. And hence we have just proven that A or B is also equivalent to saying or concurrent to saying B or A. So now we have proven that A is A and A or B, and also equal to A or A and B. And we have proven that A and B is congruent to saying B and A. And we said that A or B is congruent to saying B or A. I hope you enjoyed this video. Please like and subscribe. If you have any questions, please write them in the comments, and we'll see us next in the next Daishinfinity video. See ya.